in the text that
We are dependent on petroleum for a lot of our energy, and also a lot, not only for energy, but a lot of the products that we use. Anything that's plastic or, a synthetic rubber, or, a lot of dyes, inks, anything based on petrochemicals, we rely on petroleum for. One important contribution of earth sciences, I think, to the understanding of climate change is looking at how all of these things are interconnected, right? The most serious environmental problem is really human population. Human population, the larger the human population, the larger the, or the greater the impacts of our activities on the earth in every aspect. For mining and quarrying, I think pretty much any human activity will have an effect on the environment. Stepping out onto your lawn, even your lawn is not natural. With mining, with quarrying, you're extracting rock, you're generating dust, there's particulate pollution, there's, with respect to mining, a lot of the ores that we mine are sulfide deposits, so they contain, pyrite is being sort of probably the most common sulfide mineral. It's also zinc sulfide, lead sulfide. A lot of these metals occur in sulfide form, and partly the disposal of this material is sort of a major concern. Not so much the mining itself, but the storage and the processing of it. The short-term goal is basically managing the extraction and processing and use of petroleum responsibly. The long-term goal, basically coming up with alternative fuels that will be cleaner and will extend the life of petroleum for other purposes. There are some microbes that can actually extract gold from gold-depleted mine tailings. You can sort of extract as much of the gold out as possible. Also possibly for platinum. And then there are also methods of scrubbing the sulfur dioxide from the emissions. And you can sort of, in the best case scenario, you can scrub it and convert it to sulfate in the form of combine it with calcium to produce gypsum, which can be used as a resource, right? These rocks here are, in fact, some of the rocks that I study. They are Devonian in age, Middle Devonian in age, so 375 million years old. In this rock, we can actually see a lot of the fossils in here are actually fossil corals, okay? And we can say that if we look in the present day, we can say that most of the corals that build reefs, most of the hard corals, tend to live in the tropics, tend to live in the water. So we can say that 375 million years ago, Ontario was underwater. It was in a warm tropical sea. And it was probably at a more tropical latitude. So I always find it fascinating that you can actually look at a rock as records of what has happened in the past, what the world was like in the past. Everybody does science in their everyday lives in some form or another. It's not it's not something that, even just really smart people do. I'm well aware of my own deficiencies, and for example, I've never done well at math. I'll freely admit that, but this is something, a discipline that I sort of fell into early on, and I think it's because I think more in terms of the spatial aspects of the world and sort of bringing to synthesizing things as opposed to being sort of a linear, A to B to C. So I think earth sciences is perhaps the choice of a lot of people who do tend to think in terms of the big picture as opposed to something very, very specific.